Good morning and welcome to this presentation where we'll talk about mechanical waves. In this video, we'll discuss what are mechanical waves, list some examples, what are longitudinal and transverse waves, and explain some characteristics of mechanical waves. What are mechanical waves? A mechanical wave is a propagation of energy through a medium. Some examples of mechanical waves include sound waves, electromagnetic waves, and seismic waves. Sound waves can be generated by pressuring the air around us, causing particles to vibrate. Electromagnetic waves are created by vibrating charges. And seismic waves are caused by the movement of tectonic plates, which causes earthquakes. Now, let's talk about longitudinal and transverse waves. What is a longitudinal wave? A longitudinal wave is a mechanical wave where the direction of motion of the particles is parallel to that of the propagation of the wave. However, a transverse wave is a wave where the motion of the particle is perpendicular to the direction of propagation of the wave. This animation helps show us how transverse waves work. You could clearly see how the particles traveling are perpendicular to the direction of the wave. Now, let's list some examples for both longitudinal and transverse waves. Seismic waves can be an example for both longitudinal and transverse waves. Light waves are another example of transverse waves. Sound waves are another example of longitudinal waves. Clapping is another example of longitudinal waves. Now, let's explain some characteristics of mechanical waves. Let's start by frequency, which is the number of reformed oscillations per second. Its unit is hertz. We also have amplitude, which is the maximum displacement moved by a point from its equilibrium, and its unit is meter. The time period, expressed by capital T, is the time needed to perform one oscillation, and its unit is second. Speed of a wave, expressed by small letter v, is the speed at which a wave travels. Its unit is meters per second. Finally, wavelength. It is the distance covered by the wave in one period. It's expressed by lambda, and its unit is meters. Here are some formulas that help us calculate. There are also some special characteristics for both longitudinal and transverse waves. As we can see, for transverse waves there are crests and troughs. The highest point reached by the wave is called the crest, while the lowest is the trough. They are basically the positive and negative amplitude of a transverse wave. And the longitudinal wave has rarefactions and compressions. The compression of a wave is where the particles are closest together, while the rarefaction is where the particles are furthest apart. Now that we've discussed all of the topics, let's check our knowledge. At this point, we've reached the end of the video. Hope you've learned something new and had fun. Bye!